this video, we're going to use the formal limit definition to prove that the limit as x approaches 1 of the function x cubed minus 2x is equal to negative 1. Alright, so we're going to start with the definition. The definition specific to this example is that for any epsilon greater than 0, positive, there's a delta greater than 0, also positive, such that if 0 is less than the absolute value of x minus the 1, the approaching value of x, which is less than the delta, then x cubed minus 2x, the function minus the limit value, negative 1, should be, the absolute value of that should be less than that epsilon. Okay, so now how do we proceed? We always start with this. Alright, so we're going to start with this, x cubed minus 2x, and notice that this is plus 1 because of the double minus there. Alright, so now we need to break this up and somehow involve the x minus 1 into this, right? So if we take out the x minus 1, notice that we can complete, we're basically reducing this polynomial by power 1 because we're taking the x to the first power out, right? So that we have to start with the x squared, right? It's going to be a quadratic polynomial. And just basically multiply and do the backwards work, right? So x cubed minus x squared, there's no x squared here, so we have to add the x in order to compensate for no x squared, right? Minus x squared plus x squared, then there's a minus x if you keep multiplying, but you have a minus 2x, so you need one more negative x, so that means you have a negative 1, and notice that negative 1 times negative 1, the final product is positive 1, right? So that's good. So now, notice that what that means is that you can split the absolute value of x minus 1 so that it multiplies the separate absolute value of x squared plus x minus 1. Alright, so now what that does is that, notice that x minus 1 absolute value is less than the delta. So that means this has to be less than the product of the delta and this absolute value of the quadratic polynomial, right? So that's going to be basically x squared plus x minus 1 absolute value. And again, if you multiply these two sides by this quadratic polynomial absolute value, the right side should look like this. So we can set this now to be less than the epsilon. We can basically express that the delta is less than the epsilon over this absolute value, right? So x squared plus x minus 1. Okay, so now notice why is this going to be less than the epsilon here is because we know that we want to set that it has to be positive delta, but also it has to be sufficiently small, right? So we're going to make it less than 1. That's very important that we realize that it has to be smaller than 1 as an ideal value of that delta. So now if you multiply this absolute value by something smaller than 1, it's definitely going to keep being less than the epsilon, right? Because this thing is the same as that, and multiplying by less than 1 makes it smaller, right? It decreases it, so it must be less than the epsilon for sure, right? So, but now that we show that the delta is less than the epsilon over this absolute value, we have to make sure that we express the delta in terms of the constant, right? Because right now this looks like a variable that the epsilon divides by, right? It has to be a constant. If absolute value of x minus 1 is less than delta and delta is less than 1, then for sure the absolute value of x minus 1 is less than 1. So what that means is that we can get rid of the bars and express it as negative 1 is less than x minus 1 is less than 1. Right? Adding 1 to both sides, we should get 0 x2. Right, so that's good. Now we can square all three sides of this inequality. We get 0 squared is still 0, x squared, notice that the direction doesn't change because all we're doing, we're just squaring, and that proportionally keeps the inequality rule here, right? So x squared is less than 4, right? Because we're squaring the 2 as well. Now, why did we need to square it is because notice that this involves a square, x squared, right? That's the highest power of x, so we should include that. All right, and now we need to somehow get to plus x and then minus 1. So what I can do now, I can add this inequality with this inequality. All right. So if I do that, I will get x minus 1 added to this side, to the middle, right? And that's what I should get there. So if I add, I should get negative 1 less than x squared plus x minus 1 is less than 4 plus 1 on the right side is 5. Notice that we should have the x squared plus x minus 1 on the bottom. And this one looks like it would be on the top if we divide it by 1. So we have to take reciprocals. Okay, so just comparing these two sides, we don't need to worry about that negative 1 because we know this will be with absolute values, so the negative 1 is irrelevant there. So we can just compare these two. That means that 1 over 5, if we take reciprocal, should be less than 1 over the absolute value of x squared plus x minus 1. Right? So this is good news because we have to have the epsilon over that. So what does that mean? I can just multiply these two sides of the inequality by the epsilon. So that means epsilon over 5 is less than the epsilon over x squared plus x minus 1. And what does that mean? That means that we can actually set the delta being equal to that, right? Because both of these are less than the epsilon over x squared plus x minus 1, right? So we can set these equal. So delta could be set equal to the epsilon over 5. Right, so now that we have that, we can easily finish this proof, and we can say that if 0 is less than x minus 1 is less than epsilon over 5, right? Basically, we're copying this. Instead, we're replacing the delta with the epsilon over 5. Then x cubed minus 2x minus negative 1. Okay, so our goal is to start with this and finish with less than the epsilon, and just write as x cubed minus 2x plus 1, like we changed from here to here, and then set it equal to the x minus 1 times x squared, like this part right here, plus x minus 1. And that should be less than the delta, which is epsilon over 5, as we decided by finding this out. So epsilon over 5 multiplied by this, right? Multiplied by x squared plus x minus 1 absolute value, which should be less than epsilon times x squared plus x minus 1 over x squared plus x minus 1 absolute value. Now what is that? How did I get that? How did I get multiplication and division by these two? Well, again, notice that what I'm doing here, I'm using this inequality right here. Because we derived that the epsilon over 5 is less than the epsilon over that absolute value of the quadratic polynomial. Right? So if you think of epsilon over 5 multiplied by the quadratic polynomial being absolute value, then that means you should also multiply this side by the absolute value of the same quadratic polynomial, right? Which is why you get that part, right? The numerator gets multiplied by that. But the magic part is that now these two cancel out, and we get the epsilon on the right side. So what did I show? I showed that the left side we started with is indeed less than the epsilon. Okay, so we've successfully showed that this proof works, and indeed the limit as x approaches 1 of the function x cubed minus 2x is equal to negative 1. Thank you so much for watching, and I'll see you in my next videos.